Myself Vanasundaram Natarajan. I am working as an assistant professor in Mallarity University, Hyderabad. Today we are going to see the laser diffraction to find the wavelength of the laser beam. Okay. For that we have a setup, laser beam, and we have a diffraction grating. The diffraction grating, it has been written like 2500 lines per inch. Okay, so we have to calculate the number of lines per centimeter. First of all, we have to change the number into number of lines per centimeter. So 1 inch equal to 2.54 centimeter. So we divide that 2500 divided by 2.54 will give the value of 984.25 lines per centimeter. So to find the wavelength of the laser beam, we are going to use the formulas lambda equal to sin theta by ln, and to find the sin theta value we have another formula, that is x by square root of x squared plus d squared, right? So we have a laser beam. Similarly we are having a diagram here. Laser beam along with the grating. After that grating it gets diffracted and we will get the central maximum and we will get the corresponding maximum points. So the distance between the grating and the screen, that is your D, and the corresponding maximum distance that will give the values of 2x. Here you can see from the setup. I will switch on this. So now we are getting the diffraction pattern like this. This is your central maxima, and here we have the first order 2x value from the center to right as well as left. Similarly, the second order maxima is from this point to that point, and similarly we can have a third order from this point to this point. Okay, so this is your central maxima and the corresponding maxima for order 1, and the second one is corresponding order for n equal to 2, small n equal to 2, and the third, this is n equal to 3, and we are getting a corresponding maximas. So we are getting a diffraction pattern like this. To measure and for the visibility of the video, we are switching on the again, and now you are able to see the diffraction patterns. Now we are going to calculate the distance between the grating and the screen. That value will give small d. D is the distance between the grating and the screen. Okay, now I am fixing this from 30. Okay, and I am calculating the distance between the first order maxima. Here I am getting near about 4.4. okay, the distance between the first order maximas, corresponding maximas. Similarly, I am able to find the second order maxima distance, that is coming around 8.4. okay, so I am noting down the values. Here you can see the values. For 30 centimeter first order I am getting 4, and for second order it is coming around 8.2. so this value will give 2x values, and we can divide by 2, that will give the values of x. Then you can find the value of sin theta by using the formula x by square root of x squared plus d squared. Okay, then you can use the first formula lambda equal to sin theta by capital N and small n. Capital N we have already calculated. This is 984.25 centimeter, and small n is the order of the corresponding maximas. So by using this formula you can find the wavelength of the laser beam. So for the calculations we have done, we are getting everything in the centimeter. We have noted down everything in centimeter. So you will get the lambda sin theta value lambda, that is in centimeter, into 10 power minus 5. I am getting near about 6.7 or 6.8, 6.9 like that. So I am taking the average of that. So I am getting 6.775266 into 10 power minus 5 centimeter. So for the conversion of Armstrong, 1 Armstrong equal to 10 power minus 8 centimeter, or it is equivalent to 10 power minus 10 meter. So 6.77526 into 10 power minus 5. So I am multiplying by 1000 and dividing by 1000. So I am able to get in the if I multiply, I am getting 6777 5.26 into 10 power minus 8 centimeter. So I can write the result. The wavelength of the laser beam is found to be 6775.26 Armstrong. Okay, thank you for this.